Welcome to Pre-Calculus class today. We're going to be talking about transformations of functions. So we're seeing how shifts, reflections, non-rigid transformation works, what effects they have on graphs of functions. So we're going to start with rigid transformations. Rigid transformations is where the shape of the graph doesn't change, it just moves around a bit. So we're going to investigate f of x equals x squared, which is a basic quadratic. We're familiar with this from our parent functions. And we're going to start over on Desmos with this. You can see that I've already graphed x squared, and there's our parabola. So the first question that we want to ask is, what happens when you add something onto the end of this? So if we do x squared plus 3, let's say, what effect will that have? And as you can see, our parent function is in red, and then the purple one shows how it's changing. So when we add 3, we just moved our parabola up 3 units. Well, what's going to happen when we subtract 3? And as you might have already guessed, it's going to move it down 3. Okay, so that's great. So now we know we can add or subtract anything onto the end to move it up or down. Now, if we want to move it left or right, we have to add things on the inside of parentheses. So maybe x minus 3 squared. And when we do the minus 3 on the inside of the parentheses, you can see that our function has changed. Remember, the red is the parent function, and it's shifted to the right 3 units. Now, we subtracted 3 on the inside of the parentheses, so when we do stuff in the parentheses, it operates exactly opposite of what we would expect, because normally minus 3 we would think it goes to the left, but since it's inside the parentheses, it actually goes to the right. So something to keep in mind. So then if we change this to addition, if we add 3, then that's going to put it to the left. Great, so now we know how to move a parent function up, down, left, and right, which is a really good start. The next thing I want to look at is what happens when we make the parent function negative. And you can see from this, it just flips it over the x-axis. So we have a reflection over the x-axis. Okay, well, what happens if we put the negative inside the parenthesis? And as you can see, the new graph is exactly on top of the old one. It's a little tricky to see what's happening here, so we're going to switch to x to the third power instead. Okay, so here's our parent function. We're going to look at a cubic to get a better idea of what's happening. So here's our cubic function, x to the third, and now I want to look at what is the effect of putting the negative on the inside of the parenthesis. So negative x to the third power. And this one shows us a little bit better what's happening. This is actually a reflection across the y-axis, and you can see that here. If we go back to our quadratic, we can see that's what's happened here. It's just, since this graph is symmetrical about the y-axis, it's not as obvious what is happening. So let's go back to our notes and summarize what all we found about our transformations. So if we have a function and we add c, the effect that that's going to have, it's going to shift up c units. Okay, so whatever you add over here for the c, it's going up. If you subtract c, that's going to shift down c units. If we add c on the inside of parentheses, remember this is the opposite, so this is going to shift left. Remember, this one's opposite of what we normally think, c units. And if we subtract c, that's going to shift right, c units. If we make the whole thing negative, that reflects across the x-axis. And if we put the negative on the inside of the parentheses, that's another reflection. This time it's across the y-axis. So those are a few of our rigid transformations.